Systems of linear equations and alignment matrices. So take a moment, pause this video, read all this information, get a good understanding of what each part is. Example 1 says determine the size of the matrices. All right, so when we look at this, we notice we have 2 rows and we have 3 columns. So the size of this matrix is a 2 by 3. Example 2 says find the size, and we want to determine if it's a square matrices, a column matrices, or a row matrices. So for 1, we have 3 rows and 2 columns. So the size of this is a 3 by 2. Now we need to determine if it's a square or if it's a column or a row. So let's talk about this right quick. And if you need to, I would go back up to the top here, and we could do that. If you want to, go back up to the definitions here. It says that a square matrices means that the rows and columns are equal. So if we go back here, is the rows and columns equal? No, it's a 3 by 2, not a 2 by 2 or a 3 by 3. Okay, column 1. To be a column matrices or a row matrices, it says that you have to have 1 column or 1 row. Well, we have more than 1 row and 1 column, so it's none. It's neither. None of these. So this is not this matrices is of no specific type. No special type. All right, let's do example 3. Example 3 says find the elements on the principle of the dialogue. All right, so when we read this, let me come over here and write this. This is helpful. We have column 1. So we have row 1, column 1. Row 1, column 2. Row 1, column 3. We have row 2, column 1, row 2, column 2, row 2, column 3, row 3, column 1, row 3, column 2, row 3, column 3. Okay, so acknowledging this, we'll be able to find the dialogue or diagonal, sorry, diagonal. So if I do the diagonal, then that means I'm looking at row 1, column 1, it's 12. We're looking at row 2, column 2, row 3, column 3. So that's answering this question. That's 12, -14, 18 is our answer. Okay, example 4. We're going to write the coefficient matrices and alignment matrices of the given system of the linear equations. So let's write it down. What we're doing, we're just literally going to write it in our matrices format. So we got 6, 2, bar. This bar represents the equal sign. 2, -9, 8. And that's all they're asking for here. Okay, example 5 says perform the row operations. So this is telling me that I am interchanging row 1 and row 2. All right, so for interchanging row 1 and row 2, remember this is row 1, this is row 2, we're just going to interchange them. So row 2 becomes row 1 now. And row 1 becomes row 2. And this here is some really good, helpful information. If you want to write it down, it tells us that these arrows here is interchanging, meaning the rows are interchanging. This is K constant, some number, some constant times this specific row, and we're interchanging the rows. This one here says, again, we're going to multiply it to some row, add it to another row, and then we're going to move it to another row. Okay, so we're replacing. So number 6 says that we got -6 times row 2, and we're going to replace it into row 2. So that means I'm going to leave row 1 alone. So I'm going to write it where row 1 is left alone. And you can write all this here. I like to do it here, but sometimes it's confusing. So what we're going to do is we're going to take row 5 over here, and I'm going to multiply -6 to every part of row 5. Okay. Okay, so now we can plug it back. Now, what I was saying a while ago, I'll show you right quick what I like to do. I like to take whatever row I'm changing and leave it in that row, and just because I'm a visual person and this is what I like to do. But some of you are going to like it this other way that I did on the side where you list it. And this is how I like to do it. And I just put my equal sign underneath it, and I put what my new number is. And that's what I like to do. But if you prefer this method over here, that's fine too, just whatever works for you. That is our answer. Okay, so let's do our next example. It says perform the row operation. So now we're going to have -6 times row 2. We're going to add it to row 1 and replace it in row 1. All right. So I'm going to do it the way I like to do it. But again, if you want to do it different, you can. I'm making my box bigger because of the fact I'm going to do a lot of work inside it. This says I'm going to take row 2 and multiply it by -6, add it to row 1, and then plug it back in row 1. So row 1's changing. So I'm going to take my -6 and my number from row 2, add it to my number in row 1, and then I'm going to have equals. I'm going to take my number from -6 times my number from row 2, add it to the number in row 1. Here's my equal, and I'm going to put my bar here to represent this, everything on this other side. So I'm going to take -6 times that -2 from row 2, add it to 3 from row 1. Now I'm just going to bring everything on row 2 because we're not changing row 2. Now we're going to say -6 times 4 is a -24, because when we add it to 0, we just get the -24. -6 times -7 is positive 42, plus a -2 gives me 40. -6 times -2 is 12, plus 3 is 15. So now I have my new matrices performing that row operation. Example 8. Of course, let me go back here, guys. Of course, my final answer would look like this. It wouldn't look like all that math work. This would be my final answer. I should have done that on the one above it as well. Example 8 says, solve the system of equations using the alignment matrices method. So for first things first, I need to write it in my matrices. So I'm looking at this one here, this first equation. Get 1, -2, -9. I got 2, -1, 6. All right. Now I want to solve this. I know that okay, so we're using x1 and x2. Normally when I do a matrices, I go x, y, and then the number value, whatever that constant is, right? X, y. However, in this one here, they're doing in the textbook that I'm pulling from is using x1 and x2. So we just got to be careful. But in our end result, in order to solve for x1 and x2, if I can come up with some number in a order pair, actually it's a listing because we're not saying x, y, but if I can come up with some value for each row, then that means I have a unique solution. Okay. However, if I come up with something where I got 0 is equal to 0, and I come up with something that's true, so it could be 5 equals 5, whatever it may be, that means it's infinite many solutions. If I come up with something where I have 5 is equal to 0, then there is no solution. Okay, so let's solve for that. And let's see if we can come up with a solution. All right. What I want to do first is I want to make sure there's 1 in the first spot, right? And we do, we have 1 there, so that works out great. So next I want to find 0 here. And in order to find 0 there, in this case here, I'm going to have to perform some operations to get that 0 there. So we're going to do some row operations now. So if I said -2 times row 2, right? And we add, or excuse me, times row 1, sorry. I meant -2 times row 1. Be very careful, guys. Plus row 2. And I'm going to plug it back in row 2. So what am I saying? I am saying I'm going to leave row 1 alone because I got the 1 where I want it right now. So I'm going to take -2 times that 1 from row 1 and add it to 2. Well, -2 plus 2 is 0. That's what we wanted, right? I wanted 0 there. But remember, I still got to continue on. Let me give myself more room to this next one. So now I'm going to take -2 times row 1, which is -2, plus that -1. So I got -2 times -2 is 4 plus a -1. So it's equal to 3. And then here I got -2 times -9 from row 1 plus that 6. So I got 18 plus 6 is 24. All right. Now, what I need to do now is I need a 1 right here. So I'm going to have to perform an operation in order for me to get that 1 there. I'm going to say, all right, let's take 1/3 times that row 2 and plug it back in row 2. Okay, so I got 1, -2. I'm leaving row 1 alone. So I'm going to take 1/3 times 0, which is 0. I'm going to take 1/3 times 3, which is 1. You got -9. Okay, so I'm going to take that 1/3 times 24, which is 8. All right, we're doing good. So I got the 0, 1 in that second row. Now I need a 0 right here in the row 1, right? So we need 0 there because once I get 0 there, then I can actually make a statement what x1 is and x2 is. So, and let me just show you. So this is x1 and this is x2, if that helps. Okay. So what do I need to do? I need this -2 here in row 1 to go to 0. So what if I said, okay, I said 2 times row 2. Okay, what if I said 2 times row 2? And then I turn around and multiply that to, or add that to, I don't know why I said 2 times row 2, add it to row 1, and plug it back into row 1. So let's do that. All right. We have now remember that's 0 there, and that's why it'd be easier if I wrote it out neater. Let's write it out neater so I don't get sidetracked in all this writing. All right. Now 2 times row 2, but we're plugging it into row 1. So we got 2 times 0 from row 2 plus that 1, which is just 1, right? Now I have 2 times 1 plus that -2. Well, that gives me 0. That's what we wanted. 2 times 8 plus that -9. So I got 16 minus 9 gives me a -7. Now let's bring our answers that we already have for row 2. Now let's just rewrite this one more time. Nice and neat. Awesome. Now we have what we need. We can make a statement. x1, remember this is x1, because if I was to write this out, I would say x1 plus 0 equals -7. Now I know what it is. x1 is -7. This one here says 0 plus x2 is equal to 8. So I know what x2 is. And it's 8. And that's my answer.